All right, we're going to have a little review of Chapter 5's test, Form E. Now, if you had Form F, again, the examples are the same, the answers are the same, but they're scrambled. So you'll just have to check it out and see which one you have a problem with. And as we come along, again, this is going to be a good review for your final exam. So as we start off here we have this graph. It's a parabola, and we want to find when, in a sense, y equals 10. So there's our y equals 10 line, and we're looking then for our x values. So as we go down here, we see x is a -2. As we go down here, x is a 5. So -2, 5. Now we could have done this algebraically, and you can do it that way if you like to. You just use this equation, solve it, equal it to 0, and factor it, and you get these answers. That's the other way of doing it. Now, in this case, example 2, what we're doing is we're looking for the zeros. That is your x-intercepts. When y is 0, what is this? Y is 0, what is this? Well, in a sense, this one is going to be x minus 8 equals 0, x equals 8, which is what this one is. And this one, it's going to be 2x plus 17 equals 0. So when you solve this, this is x equals a negative, transpose that, divided by 2. So another way to look at that, that is a negative 8 1/2, which is right there. There's 8, there's 9, a negative 8 1/2. This was a little tricky, but that's how we've done it. And again, if you were to FOIL this, you would get the equation of that parabola. Okay, next one. Write an equivalent expression by factoring out the greatest common factor. So as we look at this, we could take a 4 out of each term and a y to the second out, which is what I've done here. Generally, you don't put the 1, and there's your answer. Now here they want an equivalent expression by factoring out a negative coefficient. So we're going to factor out the greatest common factor, which is 2x, and a negative 2x. Now when we do that, this sign changes. So what's in the parenthesis is a positive, and this sign changes from a negative to a positive. Notice if you distribute that, you get this answer again, and then it's matching up which one it is. And again, you want to try to do the work. That way you can just pick out the answer, as opposed to trying to do this and see which one the answer is. All right, let's raise it up a little. Now here they're asking us to factor this, and this is 4 terms. So we're going to factor by grouping. So what can we take out of our first 2 terms? An x squared, and we get this. Now we want to have this over here as well. What do we have to take out of these 2 terms to get this? And the answer is a negative 10. So now we take our 2x, or I should say our x squared, put it there, our negative 10, put it there, and then this is our common factor. Now notice the way they write it, they put this one first. So that's no big deal. You could switch these around and both are acceptable. You just had to pick out the one that matches. Okay, solve using the principle of the 0 products. It's in standard form. We're going to factor out a b, and we end up with this. Then we take each of our factors and equate it to 0. Here, this is b is 0. Here we just transpose the negative 15 to the other side and get a positive 15. And that's what we have. Okay, down in this one, it's just factoring. And on your loose leaf paper, hopefully you've written this. You put 2 sets of parentheses, tried it out, and then foiled it to check it. And I did this one just like that. Number 8, is it in standard form? Yes. Is there a common factor? Yes. So I put the common factor there, and you need to have this intermediate step. And then now I have to factor this. And again, when a is 1, it's sort of easy. And then 66, 6 times 11, and the difference is a positive 5. Watch the signs, foil it to check. And again, notice here they have this one there. They switched it around, but you just have to match it up. And that's a little bit of a challenge too. So, you know, that way you have to check it carefully. Be sure you're putting the letter in this column that you wanted. Okay, here we look at this. Negative and a negative, so one's going to be positive, one's going to be negative. And again, since a is 1, there's a u, I should say the u, well our a is 1, the variable is u, then it would be a 1u, we don't write the ones, and then a 2 and a 7, get a difference of 5. Since it's a negative 5, the 7 has to be negative, and you foil it and check to see that it's correct. And this one was exactly like mine. Okay. Let's raise this up a little bit now. So here it says solve by factoring and using the principle of the 0 product. Is this in standard form? No. So I'm going to move everything over to this side. That'll become a negative 2y. This will become a negative 15. And then equal it to 0. Factor it and equate each of my factors to 0. So here y is negative 3, opposite side. Here it's a 5. Use the graph to solve. So again, you're finding the zeros, or in a sense, the x-intercepts. And it's a negative 5 and a positive 3. When it's like this, it's so easy. If you factored that, you would factor it into that as well. Okay. Raise it up some more. So here is basically another parabola, and we're going to factor it. And again, when A is 1, it's a lot easier. And there's the steps. Again, anytime you want to pause to look at it in more detail, you can do that. Now, here is one where they give you the answers. They want you to reverse it and get the equation. So, if our answers are a negative 9, over here it was a positive 9, positive 8, negative 8. So there are my factors. I FOIL this, and I got this, and that was A. Now, as we do some of these others, I'm mentioning the word use a pencil. Because I don't know if you can tell here, but I was erasing. Now, I know what the answers are because I have the key over here. But I want to factor it myself so that I can see what the answer is. And this is what I've done. So when I FOIL it, it does check out and give me this. Now, some of these others are, they made these wrong answers very well. So again, really double check your work. All right, at number 15, is there a common factor? It's in standard form, and the answer is yes. There's a 3 in every one that I factored out. Now, I was trying here in ink, and it kind of went all right, but again, this is wrong. The signs are wrong, everything's wrong. So, except for the 3 that I took out. So again, I should have been using pencil so I could erase it. And then when I FOIL this, it now checks out and it works out very well. Here again, it looks challenging, and you might have tried an 8 and a 1, but these numbers are not big enough for that. So I tried a 4 and a 2 with pencil, then a 3 and a 3, and I noticed my middle sign was negative, but my end sign was positive. So when I FOILed it, it checks out very well. And these, since you know what the answers are, they should be pretty straightforward, although, again, if you didn't really work it and check it, you know, you're losing some easy points in a sense. Okay, now for this one, again, now I used the hints actually that they gave me down here, that I saw a 4 to 3, so I didn't see any 12s there, although there was a 12 here. I tried the 4 and the 3, and then I went for 10, a 5 and a 2. All the signs were positive, and then when I transposed that, I got a negative 5 divided by 4. I got a negative 2 divided by 3, and there were my answers. Now again, if they gave you the answers, how would you get to the equation? Well, by putting these into its factored form, keeping in mind the 4 is what's next to the y. The 3 is what's next to the y. Wow. Okay, so we want to be able to work forward and backwards. And it's the same for number 19. I have it all worked out here for you. Then going on to number 20, what are they asking here? Well, let's raise it up a little bit. They are saying that this equals 7, which is what I have right there. This equals 7. But again, to solve it, I have to put it in standard form. So I transpose the 7. That makes it a -7, and another -7 gives me a -14. Then I factor it, and I get my solutions. Notice I got the 2 first, and then the -7. They have it listed that way. That's okay. Now, to find the domain of function h, we're looking at what values in our denominator would make x a 0. So we just take our denominator, equal it to 0, factor it, so as we do this then, we find that for the domain, if x were a 2, that is, if we squared 2, we get 4. 4 times 2 is 8. 4 plus 8 is 12. 12 minus 12 would make this denominator a 0. So when we are defining the domain of this function, we cannot use a 2. We also cannot use a -6, because a -6 would make this a 0 as well. So in set builder notation, we say then that x is a real number, but x cannot be a 2, and x cannot be a -6. Well, we had a few phone calls in there. Let's see, one from my son and one from another colleague here. Okay, so I think we've covered that. These cannot be part of the domain. That was set builder notation over here. And then if you wrote it in interval notation, you would go from -infinity, comma, up to a -6, stopping just before 6, but in union now, starting up again after -6, going to 2, stopping just before 2, union, and then picking up on the other side of 2, going to positive infinity. Okay. Now, here we're getting into what is called the perfect square trinomials. That is when the first term's a perfect square, last term's a perfect square, the square root of 36 is 6, double it, you get a 12. Okay. And then it's written in this form. So again, you might practice squaring this, multiplying these two together, doubling it, squaring that, to get that perfect square trinomial. Let's go on here. Now here we had to factor out a 5, which I did up here, and then you get a perfect square trinomial inside, and it looks like so. Okay? Now here, these are both perfect squares. There's a negative sign between them. So this is what we call the difference of squares. But before you do that, you had to factor out a common factor of 25. And then now this will factor into its conjugates. So there's the 25, and then the conjugates of that is this. Again, they don't make really wrong answers. You have to look at it very carefully. All right, here's a tricky one too. This is a perfect square, and this is a perfect square. And you have the difference. So it'll be 6 plus this, 6 minus this. And then here you can just take away those internal parentheses. And then here you had to distribute that negative. So the x is negative, and this one becomes negative. Again, a little tricky. And you want to solve this function such that it equals a negative 81. So we put it in standard form, equaling it to 0. This is a perfect square trinomial that factors into this, that equals 0. So we can just write it twice, and we get x equals negative 9. Now, since the answer is repeated, we only write it once. They're both negative 9. Should be negative 9 and a negative 9, but we use the policy of if it's repeated the exact same, we only write it once. Okay, here we're finding the zeros. We factor out the 2. We get the difference of perfect squares. We factor that into its conjugates. We can divide everything by 2. In a sense, these just disappear. And we get x is a negative 5 here. X is a positive 5. So here the order doesn't really make any difference. Okay. Going on now to number 28. We have the difference of perfect cubes. And we said the recipe was a parenthesis for 2, a parenthesis for 3. Whatever sign is there goes there, and then the opposite sign goes there. The rest are all positive. So the cube root of that is x. The cube root of that is negative 3. And then we square this term, multiply these two together, and square this term, gives us that. Okay? Now there is a little mystery about this sign. Where you're multiplying these together, you'd think it'd be a negative. It's a positive because of that other rule. Whatever sign is there is negative, then it's the opposite. And you can check this by long division. Okay. And that's right here. Now, by the way, this is a skill you're going to need for chapter 6. Now for 29, we factor out the y. We get the sum of perfect cubes. Again, this part, we put parenthesis for 2, parenthesis for 3. Whatever sign is there goes here. And the opposite sign goes there. And then we take the square root of the cube root of this, which is z. Cube root of 8 is 2. Square this, multiply these together, but again, the sign is negative, and then you square that, you get this. Okay? Again, it's a technique we're going to use in chapter 6. Now here they want us to solve an equation which is the difference of perfect cubes. So again, a parenthesis for 2, parenthesis for 3, take the cube root of this, and that sign goes there, which is 5x. The cube root of a 64 is 4. We equal each of these to 0. But here we can't factor this. This doesn't factor. So we can't do anything with this. But we know one of the solutions would be this. So we equate that to 0, transpose the 4, becomes a positive 4, divide by 5, we get this. Okay? Now this is a little tricky because you can't factor this, and where you should have normally 3 answers. Now in a later chapter we will be able to factor it. We'll use the quadratic formula. Okay, let's continue. We're almost finished. Now the sum of an integer and its reciprocal is 10/3. So there's a number, we don't know what it is, it's an integer, plus its reciprocal is equal to 10/3. So how do we solve this? Well, we solve it by multiplying each term by the lowest common denominator, which happens to be 3n. So 3n times n is 3n squared. Now the n cancels out with this n, and we end up with a 3. The 3 cancels out, and we end up with a 10n. We transpose the 10n to the other side, put it in standard form, factor it, and we get n, kind of ran out of room here, is a positive 1/3, n equals 3. Now when we look at our answers, the only one we have there is 3. And the reason for that is that 1/3 is not an integer. Okay? It's rational, but it's not an integer. So the only integer of our answers, 1/3 or 3, is 3. So a little bit tricky there too. But interestingly, the 1/3 works in that original equation as well. And number 32 was a little heavy, gotta admit that. Okay, so I made a picture of the rectangle. This is the width, and this was the length. The length is 8 more than the width. Now if we cut that down and take 4 away from the 8, we get a 4 there. And if we add it to this width, it's this. So we have then factors this times this gives us this area. So it's this squared equals that. So we FOIL this out and get a perfect square trinomial equals that. We integrate that to the other side. Gives us that. We factor that, and I guess we don't see that here. I gotta move that down here. There we go. We factor that, and we get W equals 14. W equals a negative 22. Well, we reject that one. But our W then is 14. And 14 plus 8 is 22. And that's what we have. Now again, I'm doing this quickly. It took me longer time to do this. You know, I worked it out. I had to sit down, and I'm keeping this tape to about 29 minutes here, which is what I want to do here. All right, let's wrap it up.